MyTutor online school tutorial. Today, GCSE Maths, and we're looking at circle, arcs, and sectors. If you don't know what those are, don't worry, we'll go through all the relevant terminology soon. So this session will be 1 hour long, so it will finish at 3 p.m. And this is me, Molly, who is taking the session. I've done loads of lessons with MyTutor and lots of these now as well. So hopefully that means I know what I'm doing. We're going to start today with a Kahoot as usual. So let me just grab that up. Normally I have this up, but I haven't today. Sorry about that. So yeah, the format of this lesson will be as usual. If you're new, it's we'll start with a Kahoot at the beginning, just a short kind of one to see where you're at with everything. And then we'll go through the lesson content, and then we'll finish off on another Kahoot at the end, a different one, but of a similar level. So I'll explain what the content is today once I've got this up so that you can be joining whilst I'm talking. Okay. Here you go. So you can enter this pin on the Kahoot app or kahoot.it, just on your computer or on your phone, whatever. Circles, sectors, and arcs, what on earth do those mean? So we'll be going over this properly in the lesson, but an arc is like a little bit of the circumference, basically, just a little section. And a sector is a bit of the area. So if you imagine cutting out a slice of cake from a big circular cake, the slice that you've cut out, that's a sector. And the edge of the slice that you've cut out, that's an arc of the circle. So that's the basic terminology of what it is that we're covering today. And then we'll be looking at how to calculate arc length and sector area. So we're going to start off, and the first of the Kahoot questions as well will just be about area and circumference of circles. So seeing if you remember the formula for them and if you know how to implement it and use them. So yeah, hopefully that will make sense. Cool. There are a few people not in the Kahoot yet. Just let me know if you're waiting, and if nobody's waiting, then I'll go ahead. I like these names. 2 + 2 is 4, -1, that's 3. That's good. Well, good coordination there. Cool. Nobody's told me that they're waiting, so I'm going to go ahead and get started with the Kahoot. I'll keep it. Oh yes, someone just joined saying quick maths. Nice. Fantastic. If you three could get top 3 in that order, that'd be great. So yeah, you could join whilst we're doing it. Okay, so first question, hopefully an easy one if you know the formulas. So what is this, the formula to find? Got a nice little diagram there. In fact, on the picture, it actually says it down here. Wiki how to calculate the circumference of a circle. I should have cropped that out. This isn't my question, so. But well done, everybody knew that one. So what is this, the formula used to find? A equals pi r squared. Cool, nice. So this is the area of a circle. If you put ever of a rectangle, not that far, it is an area. Again, probably by the fact that it's A. But yeah, anything with pi in is probably going to be to do with a circle. And we'll go over these properly. So just thinking about circumference now, the full circumference, how can we use the formula that we just looked at? And if you need to quickly Google the formula, go for it. How can we use that to find the circumference of this circle here? Perfect, yeah, well done. So just using that pi d, so just timesing 12 by pi. Okay, now area. What's the area of this circle that you're going to get? And this is an American one because it's 7 inches. Not that the units matter, but yeah. Yeah, cool, well done. So that's by using that formula pi r squared. So do 7 squared and times it by pi. Again, I'll be showing you properly all of this stuff. Okay, so now we're going into the bulk of the content for today, so arcs and sectors. If you have no idea, that's totally fine. Take a guess. I'm expecting not many people to know how to do these. So yeah, don't worry. But if you don't know at all, either give it a stab or just guess quickly, because so that the time goes quicker. But I will leave it the whole way in case people are wanting to work it out. Okay, so only one person got that. It might have been a fluke, but we'll see how to properly do that in the lesson. I'm quite glad that those ones aren't as strong, because otherwise there's no point in me being here. So this one, it's not just the arc length, we want the whole perimeter. So you can probably take a guess by seeing that the radius is 10 centimeters and just kind of roughly what you think that would be. I would never advise doing that in an actual exam, but you know, for the sake of this Kahoot, you may as well take an educated guess. I left quite a lot of time as well, so I'm sure it'll skip once everybody's answered, but we'll see. Cool, well done. So that's might be from working it out, probably from educated guesses, kind of knowing that it's going to be a bit more than 20. So both of those guesses were sensible, so well done. Always best to have a good guess. Okay, so a bit harder to guess this one. We want to calculate the sector area. So the area of that, I don't know, cake slice, pizza slice. All my analogies seem to be food. Probably says a lot. But give it a go, even if you're not sure. Okay, I'll let all of the time go down in case people are, oh, there you go. Okay, cool. Again, possibly educated guesses, but that's really good. Well done. Right, final question, another sector area question. I'll again let the time go down, so if you're not sure, just get it in quickly so that we can move on. But again, feel free to take an educated guess at it. I'll let the timing go all the way down. Awesome. Cool. Well done. Okay, so that was actually a really, really well answered quiz. So it's going to be difficult to beat that for the final one. -1, that's 3 in third place. 2 plus, oh, come on. If quick maths is first, this will be the. Oh, Prussian gang, well done. I loved some of those names there. But yeah, 8 out of 8, that's fantastic. Really, really good. Top 3 there, and everyone did really well. So 67% correct for the beginning quiz is fantastic. So that's going to be tricky to beat at the end, but we'll give it a go. Hardest one was this arc length one here. That's okay. We'll give it a good go. Okay, so let's jump straight into it. So the first thing that we're going to do is some terminology. so that when I'm throwing around these terms about circles like arc and sector, you actually know what I'm on about. So what I'm going to do is I'm going to draw a circle, draw various things on them, and tell you what they are. So first thing is that you will probably know is that the distance right around the edge, the perimeter of a circle, is so special that it has its own name, which is circumference. That I'm sure you're all familiar with. And then we've got the two terms here. So if this is quite important for me to draw actually on here, the center of the circle. That's not bad actually, that looks quite central. So the distance from the center to the edge, that's called the radius. And the distance from one end of the circle to the other passing through the center, so like this, that's the diameter. And that diameter is twice the radius because, you know, you go to the center and then out again to the edge. So that's important because for some questions we'll have to convert between the diameter and the radius and kind of seeing what, you know, if a formula uses the diameter but we only have the radius, we'll have to double it and so on. So those are kind of the obvious ones. Now, here are some that you might not know. So this first one we're not going to be looking at today, but I think it's important to cover the terminology nonetheless. So if we, oh, don't want to do that. If we draw a line like this line is called a chord. That's just a line from any point on the circle to the other. Doesn't have to go through the center. Diameter is a special type of chord, but not every chord is a diameter, if that makes sense. See, this one doesn't go through the center. And what that chord makes when it kind of, the areas that it cuts off, so kind of this area here and this area here that I'll shade, that's got a special name, and that is a segment. Now, the way that I remember that that's called a segment is because it looks like a segment of an orange or a Terry's chocolate orange. I know which one I prefer. But it looks exactly like that shape, right? That kind of straight line with a bit of a curve there. So that's a segment. As I said, we won't be using these terms today, but as I'm telling you all the other terms about circles, I thought I may as well cover it. So those are those ones. And then we've got the ones that we're covering today, which I did briefly talk about, but I'll tell you again. So this is if we draw two radii, that's the plural of radius, radii, very strange plural, like this. Then we've got a couple of things here. The first thing is that this section that it forms here is an arc of a circle. Similarly, this bit here is also an arc. Doesn't matter about the length. It's just any like part of the circumference, really. If you'd like chop a bit out of the circumference, the bit that's left is called the arc. So like I said, if you take a slice of cake, or if you take a pizza, right, the crust, that's an arc. And then this area here, this is called a sector. So I always used to get confused between sector and segment, which is why I remember the segment like a piece of Terry's chocolate orange, so that then I can remember, okay, the segment's the one like an orange, sector is the other one. And that's my personal way of remembering them. Because as I said, all of my analogies are about food. So yeah, again, if you take a slice of pizza, right, the actual slice is a sector and the crust is an arc. But equally, you could take this whole bit that doesn't technically look like a slice of pizza, but it kind of is. This is also an arc, and this whole Pac-Man is a sector. Pac-Man's a sector of a circle, and his outline is an arc. So hopefully that makes sense, all of the stuff that I'll be talking about. So let's go into the actual math stuff with formulas and things like that. And we're going to start off by looking at circumference and area of a circle. So forgetting sectors and arcs for now, we're just going to make sure we're really comfortable with the formula and using those, which based off the Kahoot, I think you all are. So this should be quite a quick section. We should be able to move on fairly quickly. So the two formula that are so key to use in this are the two that we saw at the beginning of that Kahoot. So C equals pi d. The circumference is pi times the diameter. And this is actually how pi is defined. Pi is defined as how many times the diameter of a circle fits round the circumference. I think it's quite easy to forget that, but pi isn't just this random number. It actually comes from every single circle, has the same ratio of the diameter to the circumference. And that's pretty cool. Maybe it's just cool because I'm a maths nerd, but it's cool nonetheless. So a nice simple one, circumference is pi d, which means that if you just have the radius, it will be pi times 2r, because as we know, the radius is half that of the diameter. Other one, I guess a slightly harder formula, is pi r squared. And the trickiest bit about this is remembering that it's just the r that is squared. So if you've got the radius of a circle, square that, times it by pi. That's your area. Again, if you just have the diameter, just half it before you square and then multiply by pi. And we'll see a couple of examples of these, but take a photo of this, screenshot this, save this, memorize this. These are the formulas that we're going to be using today. Even when we get onto arc lengths and sector areas, we'll be looking at these formulas. So they're important, and they're the core of today's session. So let's have a look at some example questions. Okay. Let's have a look at a worksheet here. This actually tells you everything here. Did I miss anything? Oh, tangent, I suppose, is this where it's a line that just touches the circle at one point. But you know, I got all of the others, so. Okay. We're going to find both the area and the calendar telling me I've got a webinar. That's nice. We're going to find both the area and the circumference. Oh, did I copy a line? Oh no, that was the, what? Let's go back on and screenshot this again. That's a bit better. Okay, so you've got a circle with center at X and a radius of 3.7. So they've been quite nice and drawn on the radius for us, just in case we've forgotten what the radius is. So we'll first of all find let's start with the area, because that's one that actually includes the radius. So nice and simple, all we do, remember that the area is pi r squared, and substitute some values in. So that is pi times 3.7 squared. And then you're just going to put that exactly as it is into your calculator. If you haven't found the pi button yet on your calculator, I'm not sure where they are on all of them, but it will be in like the row at the top of loads of little ones. There'll be pi, or it will be shift something. I'm not sure how calculators, but I'm going to use a Desmos calculator because, as we know, big fan of Desmos. And you'll see there's just a button for it here. So pi times 3.7 squared. So that's all you need to put. And then it will give it to us like this. So 43.008. So 43, I'm going to round that to. And then just make sure we put in our units. So that's going to be meters squared because it's an area. Yeah, brilliant. And people started to get that, which is fantastic. So what I'll do is I'll show you with this one, then I'm going to give you another one and ask you guys just to do it and tell me. And then the other one is going to be the circumference. Now we know that the formula for a circumference is pi d. We don't have the diameter, but that's fine. We can just double the radius. So this is going to be pi times 2 times 3.7. So we can just pop that into our calculators. Pi times 2 times 3.7. Boom. 23.25 if we round it to 2 decimal places, or let's just say, yeah, let's do 2 decimal places. So this should really have been 43.01, but let it slide. 23.25. And that's meters because it's a distance all the way around it there. Perfect. People are getting that, which is fantastic. Okay. So here's one with diameter 3.6. So I'll give you guys a couple of minutes. Could you tell me on the chat or the Q&A, whichever's easiest for you, the area and the circumference? In either order, just let me know which is which. And then there we go. I unplugged my headphones and then it all went a bit wrong, but I think you should be able to hear me now. So I don't have my calculator on me, so I can't, I don't actually know the answers to these. So I won't be able to tell you whether you're right or not. Because unfortunately I can't multiply by pi in my head. Not quite yet anyway. Okay, cool. We'll go through it. So this one, because we're given the diameter, in order to work out the area, we've got to half it first of all to find the radius. So if you struggle with these, best thing to do is at the beginning, write down what your diameter is and write down what your radius is, which will be half of that. And then you can just pick and choose which one to use when you do the questions. So, oh no, sorry, you're right. As someone just pointed out, the radius is 3.6. Wow, okay, that was misleading. That was me not reading the diagram. Radius 3.6. I apologize. That's me just seeing the line on the diagram and assuming that. So our diameter will in fact be 7.2. Well spotted. So our area is pi times our radius squared, which is going to give us pi times 3.6 squared, 40.72. And our circumference will be pi times 7.2 because that's the diameter. So pi times 7.2, or we can just write 7.2 pi, 22.62 if we round that. So well done. I think a couple of people got that. And people who got different, yeah, they did the diameter. That's my fault because I said it was the diameter. So if you got 11.31 for the circumference, that's correct if this had been the diameter. So don't worry about that. Yeah, awesome. Okay, let me just see if they're any more complicated, and if not, I'll go on to, oh yeah, let's do this one because this is kind of a nice introduction into what's going to start happening when we look at the sector area and arc length. So here we've got a semicircle. So that means exactly half a circle. You literally cut it across the diameter. And this has got a radius of 8 centimeters. And we want to find the perimeter of this semicircle. So does anybody, let me know in the chat, does anybody have any ideas about how we might do this one? Some people are already calculating the answer, which is nice. Cool, yeah, so divide end result by 2. Yeah, so we can divide the circumference by 2. That's exactly right. Because it's, yeah, someone else has got that as well. Perfect. So let's find the circumference of this. Remember that the circumference is pi d. And the radius is 8. So this is going to be pi times 2 times 8. And that is going to give us pi times 2 times 8, 50.265. I'm going to do it to 3 decimal places. Because the final answer we want to be to 1 decimal place, I would always work to at least 2, probably 3, and then round at the end. Because if you start by rounding to 1 decimal place, you could lose some accuracy. So I'm going to write this as 50.265. Okay, so then the circumference, so this bit here is going to be half of that, or divided by 2, whatever, it's the same thing. So we'll take our answer and divide it by 2, 25.133. Okay, now we're not quite done, because the perimeter of this full semicircle, we also need to include this bit. Now the radius is 8, so this bit here is going to be 16, twice that. So our final perimeter will be kind of the half circumference, and add it to that diameter. And that's going to give us 41.133, or to 1 decimal place, 41.1 centimeters, which a couple of people got really quickly, which is fantastic. So well done. So hopefully that makes sense, how we did that one. Let's just have a look at this one, and then we're going to move on to sectors and arc lengths. Just because this is more like the kind of exam question that would come up. So we want to calculate the area between the 2 circles. So this shaded area here, this kind of donut ring. Oh my God, I did a food analogy again. The donut ring there. So you can see that circle A, this wider outer circle, has a radius of 16 centimeters. And our inner circle here, circle B, has a radius of 7 centimeters. So again, in the chat, does anybody know how we're going to find the solution to this one? Fantastic, yeah. Area A minus area B. Yeah, calculate them both. Perfect. So let's calculate area A. So I'm going to denote that by AA, as in area of A is going to be, well, pi r squared. And in this case, r is 16. And in fact, what I'm going to do is I'm just going to write that as something in terms of pi for now. So 16 squared is 256. So I'm just going to write this as 256 pi. And then the area of circle B is pi times r squared, and this time r is 7. So that's going to be 49 pi. The reason I've done that is because it's less for me to put on my calculator. See, now I can just say that the area of the shaded region is 256 pi minus 49 pi. And that's just one thing for me to put on my calculator. So that's just kind of a little trick that I would recommend. There you go, 650.31 centimeters squared. And there you go. And loads of people either got that answer or knew how to tackle that. So well done. Okay, cool. You all seem to have a really good grip on that, calculating circumferences and areas. So let's do the step up and move on to sectors and arc lengths. Okay, let's close these. Have a look at this one. So let's do this one. So we're actually going to find both the area and the arc length here. Now, the way that we do this seems quite confusing at first, perhaps, but it's really quite easy and intuitive once you get used to it. So the reason that we divided our circumference by 2 when we were finding the perimeter of that half circle was because the circumference was half of that of the circle. If we were doing, say, a quarter circle, so where the angle is a right angle, we divide it by 4. All we're really doing there is finding out what fraction of the circle it is. So that's what we're going to do here. Now, there are 360 degrees in a circle, right? And this sector is 50 of them. So this circle is 50 over 360. That's the fraction that it is of the whole circle. So if we multiply the area or the circumference by that, we'll get the sector and arc, respectively. So for example, let's say we want to find the sector area. So the area of this bit here. That's going to be 50 over 360 of pi r squared. Because pi r squared, so pi times 5 squared, tells us the whole area of if we join this up and made it into a full circle. But then this section is only 50 of those 360 angles. So we just multiply it by 50 over 360 and we'll get our solution. So if we do that here, 50 over 360 times pi times 5 squared, 10.9. meters squared. Does that make sense? Let me know in the chat whether or not that makes sense, because I know that this is can be quite confusing when you first learn about it. So cool, yeah, people are saying it makes sense, fantastic. Okay, so we can do exactly the same thing for the arc length. So this bit at the top. Again, we can work out kind of the full circumference, and then, well, it's only 50 of those 360 degrees, so we do the same thing again. Times, now we know that the circumference is pi d, so pi times 10. Because if the radius is 5 meters, the diameter d has to be 10 meters. So let's do this. 50 over 360 times pi times 10. 4.36. Now, a common question is to find the entire perimeter, and that's quite easy because once you've found the arc length, to complete the perimeter, we just have to do this bit and this bit, and that's just adding 5 and 5. So the perimeter of this pizza slice is 14.36 meters. Gosh, that's a big pizza slice actually because it's in meters. But hopefully that makes sense. So when you see perimeter, just don't panic about it. Just think we want to find the arc length first, and then it's easy from there. So let's have a go at another. I'll give you guys one. That's a reverse one, so we will do that one in a moment actually. Here we go. So this one, tell me the arc length, just the length of the arc bit, not the whole perimeter, and the sector area. Tell me them in either order, just let me know which is which. But yeah, pop that on the chat. Cool. So a couple of people have submitted. I'll just give it another little bit of time. If you want to put your answer on, pop it on. I'll be going through it in about 30 seconds or so. Cool, people are doing really well. Okay, cool, well done. I'll go through this now. So, let's do the arc length first. So the first thing that we want to do is work out what fraction of the circle this is. Well, that's going to be 30 over 360. Once you've seen it once, it's really easy to do from then on because it's just the however many degrees are in the sector divided by 360. So nice and simple. So to find our arc length, oh, that was a bad curve. That's going to be 30 over 360 times the whole circumference, which we know is pi d. So pi times 10 again, because this also has a radius of 5 meters. So 30 over 360 times pi times 10. 2.62, which people were getting, which is fantastic. And then the area, the sector area, that's going to be the same fraction, but this time of the area, which is pi times r squared. So 30 over 360 times pi times r squared. 6.54. That took me a moment to round because it was 49. 6.54. Which again, people got, which is fantastic. And that's meters squared because it's an area. Yeah, perfect. Loads of people getting it. And yeah, if you want to give it in terms of pi, as someone's just put in here, it's 10 over 12 times pi or 25 over 12 times pi. If you don't have a calculator, that's a really good way of doing it. And sometimes in non-calculator questions, you'll actually be asked to just give something in terms of pi. So that's a really good thing to do. Brilliant. Okay, let's have a look at this one. Okay. So this diagram shows a sector of a circle with center O. And this time we don't know the radius, that's what we want to calculate, but we're given the area of the sector. So I'll give you 20 seconds or so to think about it, and then I'll go through it. You don't have to fully work it out, just think maybe about how you might do this question. Cool, people are having some really good ideas, which is fantastic. So we're just going to set up an equation. We've actually done a lesson before on forming and solving equations, if you remember that. So it's really similar to that. So let's think about if we were just given the radius as x and we wanted to work out the sector area, what would it be? Well, it would be 60 over 360, which we can simplify. That's actually 1 over 6. So that's probably a much nicer way of writing that, but I'll do that once I simplify it. So 60 over 360 times pi times r squared, which in this case is x squared, because we're just given that the radius is x. And we're told that that's the sector area, which is 18.4. So now we've got an equation. Now let's simplify this. So as I said, this was 1/6, and we can write this as pi x squared. So now we just rearrange. So what I would do is multiply both sides by 6, because then we can see pi x squared equals 18.4 times 6, 110.4. Then divide both sides by pi to get x squared. So 110.4 divided by pi, 35.14. Notice how I'm working to 2 decimal places because we want the answer to 1 decimal place. And then we can square root. So square root our answer, 5.9 to 1 decimal place. Do bear in mind that when you square root something, it's plus or minus, but obviously in this case, the radius can't be negative. So we can just take that positive answer. So it will be 5.9, not meters because it says x meters. So there you go, 5.9. So hopefully that made sense as to how I did that. And yeah, some people had some really good thoughts on how to do that. So that's perfect. Hopefully that one makes sense. Hopefully you can see that now that we know this formula for calculating it, this kind of angle over 360, it's quite nice and easy to do. So let's have a look at this one. We'll go through this question because it looks a little bit harder, and then we'll do the final Kahoot, and I'll explain each question if it needs explaining. So we've got an equilateral triangle, haven't seen one of those yet, with side lengths of 9 centimeters. And O is the center of a circle, and OAB is a sector of that circle, and OA is 3 centimeters. And we want to find the perimeter of the shaded region. So we want to find the perimeter of this kind of, it will be like a concave curve there, and the rest of this triangle. So quite a tricky one. I'm just going to jump straight into it. You can probably start to think about what it is that we're doing. So because we need the perimeter, we obviously need this kind of length here. So that's going to be an arc length. So the first thing is, what on earth is this x going to be? Now, this is a really common thing that comes up quite a lot. When we have, and yeah, some people have got it in the chat, that's fantastic. When we have an equilateral triangle, all of the angles have to be the same. And if all of the angles are the same and they add up to 180, well, they've each got to be 60. So that's the first thing that we can confidently say is this angle has got to be 60 degrees, this angle of this circle. Yeah, brilliant. People got that in the chat well. Okay. So finding that perimeter, finding that arc length first to find the perimeter, sorry. We're going to do 60 over 360 and multiply that by pi times r squared. And we're told that OA is 3 centimeters. So pi times 3 squared. So let's do that. 60 over 360 times pi times 3 squared. 4.71. Let's wait, does it say? Oh, 1 decimal place, so 4.7. So that's covered that bit. Oh my gosh, that was a bad drawing, wasn't it? That's covered that bit. And now we just need the rest. And this bit's actually really nice and simple because these bits both have to be 6 centimeters. Because if OA is 3 centimeters, that's the radius. So OB also has to be 3 centimeters because all the radii are the same length. So this is also 6 centimeters. And this one, as we're given, is 9 centimeters. So our final perimeter, is going to be 4.7, that arc length. Add those 6s and that 9. So 4.7 plus 6 plus 6 plus 9, 25.7 centimetres. And that's how we do that one. So hopefully that makes sense how we did that one. The main point of that was calculating the arc length there. The rest is actually fairly easy as long as you know your rules about circles there. So we're going to go ahead and do that final Kahoot then to see where people are at. So okay, there you go. There's the game pin. So either on the app or online. Cool. So go ahead and join this. And what I'll do is if it's a trickier question, like some of the later ones, I can properly like draw on it, whatever, and show how where these gang members coming from. Ah, you members of the Prussian gang. I see. And a smiley face and a winky face. Fantastic. So at the beginning we had 7 or 8 people in. There are 12 of you here, so I'll wait. Someone says I'm the only teacher who's ever pronounced Prussia right. Really? How else can you pronounce it? Oh, don't know where this has come from. Brilliant. Okay, is anybody waiting to join? If not, I'll get started. Yeah, said, oh God, what have I started? Tell me about it. I don't know what's happening. It's a war. Oh gosh. Oh dear. Okay, I'm gonna get started. You can you can join once we're into it. So that's fine. Okay. First question. The first 2 questions are actually the same as the first 2 before, because as I said, these formulas are so integral. That's the word I was looking for, to the core of what we're doing today. Yeah, nice. And the person who picked this one might have just seen perimeter and got a bit excited. But yeah, that one's the circumference. And what is this formula? Super speedy. I might skip because the 9th person didn't actually vote last time. Yeah, perfect. Well done. 100%. Ooh, rival gangs at the top, guys. Prussian gang, you've got to up your game. Okay, a nice simple calculation. Find the circumference of that circle there. So think about what you're going to need to do, because there you're given the radius. Think about what the formula is, what you're going to need to do there. Okay, I'm going to start skipping once we get to 8 because I think this 9th person is a mystery. Yeah, cool. Well done. So the way that we did that, times 7 by 2, 14, times that by pi. Okay, an area question this time. And we're given the diameter is 12 centimeters. So think about what you'll need to do to that before you can do anything else. I won't skip until it gets to at least 8, because I know that many people are at least active on it. Maybe not. We'll see when it gets down. Yeah, perfect. 100%. Well done. The trick was to half it before you square it. Ooh, gang member 2. Cruising up to the top there. Right, on to the content of today. What's the arc length here? So remember that formula that we used. What you're going to have to multiply your circumference by. And make sure you work out the circumference correctly, because we've got the radius there. So what are you going to need to do to that? Okay, I'll skip because 8 people have submitted. Okay, nice. Yeah, a couple of people were wrong there. So what we're going to have to do here, in fact, I've got time to go over it, haven't I? Because I started it nice and early. So we'll quickly go over this. Okay, so this one, we were looking for the area, I think, were we? Hold it. Or was that, no, it was arc length, wasn't it? Yeah, arc length. Let me make sure I'm tackling the right question. So it's going to be 115 over 360. And we want to times that by our circumference. So that's going to be pi times 40, because that's the diameter if the radius is 20. So if you pop this in your calculator, this is what you'll get. Ooh, not what I meant to click. Okie doke. See how the score's doing. Oh, staying pretty stable. Okay, this time it's the area of a sector that we want to find here. Now, it doesn't actually make it clear which sector. It's the small one, the one with the 45-degree angle. Because remember, Pac-Man is a sector as well. This one's definitely not as easy to guess, seeing as you've got some really close together answers there. Okay, perfect. Well done. Everybody smashed that one. Well done. Don't need to go through that. Okay, now this one we want to find the perimeter. So remember to calculate the whole thing. And that is the perimeter of this shaded bit. So the perimeter of Pac-Man. And the radius there is 29 centimeters. Again, I'll skip once it gets to, in fact, I think there's only 8 people in the Kahoot now, aren't there? So I'll just wait until everybody's answered. Okay, perfect. Yeah, so the majority of people got that, but I'll go through this one just because we've got time before we finish. Okay. So the first thing that we're going to do here is find the arc length. So we've got 304 out of those 360 degrees, and that's times the circumference. So that's pi times 2 times 29, because remember we want pi times d. So that is going to give us, so 304 over 360, gosh, can't type today, times pi times 2 times 29, 153.87. And then to find the perimeter, so that's found us this bit here. But then for the perimeter, we need these two bits here as well. And those are both 29 because the radii are both the same. So the perimeter is our arc length, add 29, add 29. So let's do that. Our answer, add 29, 211.87. Which is what it, or 211.9, which is what it was on here. So I think the people who put this, you just calculated the arc length. So you still did that correctly, well done. But you've got to remember to add to the 29 and 20. Yeah, someone said they forgot that. But yeah, perfect. Okay, let's first of all see the podium with all of our Prussian gang members. So gang member 4 in third with 6 out of 7. Top 2 got 7, so Prussian gang. And then in first place is gang member 2. So congratulations. Unfortunately, rival gang didn't quite make it there. The percentage was actually lower there, but I think that was because some people at the beginning weren't answering the questions. I actually think overall the percentage was higher. So well done. And look here, every question was answered correctly by most players. So that's fantastic. So yeah, look at this. I've actually finished 2 minutes early. So I'll sign off on time for once. So thank you all for coming today. That's the end of this lesson. Hopefully it's all made sense. Oh gosh, someone said maths joke. I haven't prepared a maths joke as usual. When do I ever remember? So if anyone has any, let me know now and I'll do it at the end. But hopefully everything's made sense. These are all recorded and put on the MyTutor YouTube page. So make sure to check that out if you want to watch it again. Who wouldn't, you know? And check it out for some other ones as well. And there's a MyTutor timetable for which lessons are coming up. There's also some information about some small group tutorials happening, all of that lovely stuff available on the MyTutor page. And if you've enjoyed this, loads of tutors like myself offer one-on-one tutoring, and MyTutor team can help you set you up with a really great tutor. So yeah, lots of opportunities for you there. Sorry there's no maths joke this week. I'm desperately trying to think of one, but I don't have any. Okay, there you go. Someone said one that's great, nice and simple. Circles are totally pointless because they have no point, and it's about circles. So perfect. Oh, here's another one. Why was maths class so long? Because the teacher kept going off on tangents. That's me. Perfect. And we talked briefly about the tangent of a circle. Perfect. You guys are good. Nice. Yes. Thank you for coming. Check out the YouTube page, and I will see you next week. Thank you, everybody. Bye.